Hey guys, we are looking at sequences and patterns, and these are going to be pretty easy sequences and patterns that we're going to be looking at. Maybe they're adding by the same amount each time, maybe they're subtracting by the same amount each time. Those are called arithmetic sequences, or maybe they're geometric sequences where they're multiplying by the same amount each time. Let's take a look. The directions say determine the pattern of each sequence and find the next three terms. So when I look at this first sequence, 2, 4, 8, 16, 32, I might say to myself, am I adding by 2 each time while 2 to 4 is adding by 2? But is going from 4 to 8 adding by 2? No. So I would say, okay, well, how else can I increase something? And it's possibly by multiplication. How do you go from 2 to 4? Multiply by 2. How do you go from 4 to 8? You multiply by 2. 8 times 2 is 16. 16 times 2 is 32. Pattern works out beautifully. So the way to get the next term in the sequence is to multiply by 2. So then I would take my 32 and multiply that by 2 to continue the pattern. 32 times 2 is 64. Then I would take 64, multiply that by 2. 64 times 2 is 128. And then last, take 128, multiply that by 2, and we get 256. Next one. Oh, well, 5 times 2 is 10, so maybe this next one is also multiplying by 2. 5, 10, but then it's going to 15. And that's definitely not multiplying by 2 each time. In this case, going from 5 to 10 to 15 to 20 to 25 is simply just adding by 5. So if I wanted to continue this pattern, I would go from 25, add 5 to get 30, add 5 to get 35, add 5 to get 40. Next one, -5, -3, -1, 1, 3. I can see that my values are increasing. I don't see any common multiplier that I'm multiplying each time, but I do see that these are definitely increasing by a value of 2. So I'm going to add 2 in this pattern. If I continue to add 2, my next terms would be 5, 7, and 9. Next one, do not get frightened about decimals. And if you ever are looking at a sequence and you kind of get thrown off by the negative numbers, because often students do, look at the positive numbers. What is happening from point 4 to point 2? From point 2 to 0. It's decreasing by point 2. Think about 40 cents to 20 cents to 0 cents. It's subtracting by 20 cents. And if I continue to subtract 20 cents, I would have negative 20 cents, negative 40 cents. What if you had negative 40 cents and you continue to subtract 20 cents from that? You would then have negative 60 cents, negative 80 cents, and then negative what? A dollar or negative 1. Awesome. Next one, 3, -6, 12, -24, 48. I love these sequences because originally when you look at the numbers, you say, okay, well, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. But I see that they're alternating positives and negatives. How do you multiply 3 by a number and get -6? Well, it wouldn't be 2, it would be -2. And then what happens when you multiply -6 times -2? A negative times a negative is a positive, and so it would be positive 12. Anytime you see sequences where they're alternating positive and negative, the multiplier, what's called the common ratio, is a negative number. So here I would know to continue this pattern by multiplying everything by -2. 48 times -2 is -96. So notice the pattern, positive, negative, positive, negative, positive, negative. So you know the next one's going to be positive. It's going to be positive 192. Multiply that by -2 and we get negative 384. The next one, 3 ninths, 4 ninths, 5 ninths, 6 ninths, 7 ninths. What's happening here is that I see my numerators are increasing by 1, but my denominator is staying the same. So I'm not multiplying by anything here, but what I do see is that I'm increasing everything by 1/9, right? Because we learned and we talked about when you add or subtract fractions, the denominator needs to be the same. So if I only see the numerator changing, I can see that here I'm simply adding by 1/9. So 7 ninths plus 1/9 would be 8 ninths. 8 ninths plus 1/9 would be 9 ninths. But what's a better way to say 9 ninths? Simply 1. Then if that was 9 ninths and I add another 1/9, you could technically say 1 and 1/9, but we talked about going into Algebra 1, we really want to stay with simplified and proper fractions. And so the best way to write it is that it would be 10 ninths. 9 ninths plus 1/9 is 10 ninths. Next one, 1/2, 1/4, 1/8, 1/16, 1/32. Okay, I see that my denominators are multiplying by 2. I see that pattern, but my numerator is staying the same. So if I want to say that I'm multiplying this by some value, I don't want to say 2 because 1/2 times 2 is 1. I'm not actually doubling them. What I'm doing is I'm multiplying them by 1/2. So notice the 2 is in the denominator. So then I would have 1 over 64, 1 over 128, and 1 over 256. Awesome. 6, -3, -12, -21, -30. Ooh, they're getting smaller and smaller. I don't see any friendly multiplication fact going on here, but I do see that the values are getting smaller. So let's see. What do you do to 6 to get down to -3? Well, you subtract 9. -3 minus 9, would that get me -12? Yes. -12 minus 9, would that get me -21? Yes. -21 minus 9, would that get me -30? Yes. So I see I'm definitely subtracting by 9. If I continue to subtract by 9, -30 minus 9 is -39. -39 minus 9 is -48. And -48 minus 9 is -57. Awesome. Last one. 0.32, 0.8, 2, 5, 12.5. I don't know. This one's a little tough. I mean, I don't see that they have a common difference. So going from zero point 0.8 to 2 and then 2 to 5 is not going to be the same amount. I see the values are getting bigger, but they're not multiplying. I'm sorry, they're not adding by the same thing, which would mean that they need to be multiplying by something. So basically, what can always happen here is if you see that it's being multiplied by the same amount, but you can't really tell what that value is, what you would do is you take any number in the sequence and you divide it by the previous term. And if I do that with any of these numbers, 0.8 divided by 0.32, or 2 divided by 0.8, or 5 divided by 2, or 12.5 divided by 5, what I'll see is that these are actually multiplying by 2.5 each time. And so then, especially with the decimals, we may want to grab a calculator for this. I wouldn't expect my students to be doing all of this mentally or by hand. Is then for me to continue this pattern to take 12.5, multiply it by 2.5, which is 31.25. Take that, multiply it by 2.5, and so on. You get the point. That one was a little bit of a trickier one. I hope this video helps. Thank you so much for watching. Bye.